Welcome, everyone. I'm Professor Joanne Ordilli from the Rutgers Business School, and this is Tech for Business. Are MySQL timeouts getting you down? Do not despair. Today, we will review techniques for overcoming timeouts when updating tables or inserting new data and when querying tables. We're going to talk about three different things here. First, how to choose a MySQL Workbench configuration that will resolve timeouts. Second, how to resolve timeouts when creating or updating tables. And third, what to do if you're getting timeouts when you're running queries. These slides and links to other videos I discuss in this video are available in the description to this video. Sometimes the easiest way to get around a timeout is to change your MySQL Workbench configuration. In order to do that, you need to go to Settings on Macs or Preferences on Windows, or if you look at MySQL Workbench, there's a gear right up here in the right-hand corner that you can press to bring up the settings. Once you do that, you will go down the menu on the left and choose SQL Editor, and you'll see three things here that affect timeouts. One is the keep alive interval. This means how often MySQL Workbench will send a keep alive message to the server. If you are getting something like lost connection to MySQL server, then you want the keep alive interval to be smaller. So I got one that was for about 60 seconds, meaning that after 60 seconds it timed out. So I lowered the timeout to 60 and I averted having this timeout again. The next timeout, which is set to some number by default, is the timeout for reads. You can set this to 0 to never time out on a read, so that's a good idea. And then finally, if you find that you're experiencing timeouts in making a connection to your server, this is the value that governs that. So generally speaking, I leave this one alone, I make this one 0, I max out this one. That's not all, though. The second place to go is under SSH, where you have a series of 3 timeouts for connections, read writes, and commands, and you can max all these out by setting them to 500. Now, if you've been having timeouts, go try whatever you were doing. You might find that this solves your problem. On the other hand, you might still have a problem. If what you're trying to do is load or insert a large number of rows into a table, it's important to choose the right tool for that. Many folks will use the MySQL Workbench Table Data Import Wizard, which is illustrated here. This wizard works really well for smaller tables, but for large tables, it takes an inordinate amount of time. So if your problem is loading or inserting rows from a large file, best to use the SQL load data local infile command. If you don't know how to use that, I have 2 videos, one for Windows and one for Macs, that you can use in order to accomplish that. So check those out. Suppose you've done that already. You've gone to the load data local infile command and tried that, and you're still having timeouts. In that case, the problem that you might be having is that your table definition includes a lot of constraints. It might include primary key constraints, foreign key constraints, or check constraints. Each of those constraints has to be tested for every row that you add to the table. And this is slowing down the upload of the data into the table. The solution to this is to remove all the primary key, foreign key, and other constraints from your target table upload all the data, and then add the constraints back individually after the data is uploaded. If you follow this approach, the constraints will all be validated when they are added back to the table. Oftentimes, people disable foreign key constraints as part of making a data load go faster. The issue with doing this is that the foreign key constraints are not checked when they are re-enabled, and you may have inadvertently introduced bad data into your table. So I recommend that you delete the constraints and then add them back to the table. Let's take a quick look at how this works out. I have a table that has 33 columns. There's a primary key constraint and 10 foreign key constraints in this table, and it has more than 1 million rows. This is the same table that is used to illustrate techniques for loading big files fast in the videos that I mentioned earlier. The only difference here between my use of this table is that I've added a primary key to this table, which means I had to do a bit of a manipulation to tables that are referenced by the foreign keys. So if you're using my large file data upload video, you won't have a primary key. And this is what I recommend if you follow that video and then try to do the project from my class for the fall of 2024. So using the load data local infile command to load this table took 614 seconds roughly. When I left all the constraints in. I have a very fast laptop. So if you do not have a very fast laptop, it's likely it would take even longer for you and your load would time out. When I removed all the constraints and did the load, it took only about 31 seconds to load that data. After loading the data, I then added each constraint individually, and each constraint took from 28 to 40 seconds to check. So let's take a look at what that looks like to provide context here in MySQL Workbench. So here in MySQL Workbench, we have a table freight, and this table has all of its constraints. And this is the load that took about 614 seconds. On the other hand, here's the same table without its constraints. This load takes 38 seconds roughly. And here is how I add all the constraints to the table after the fact. I alter the table, give the table's name. I add the constraint name for the constraint, that's this here, and then I say foreign key, just as I would have if I defined it in the table originally. This problem that we're talking about can happen also if you're doing a large-scale insert to an existing table or you're updating a lot of rows in a table. So whenever you're having a problem with inserts or updates, consider whether or not the constraints on your table are getting in the way and whether you want to remove the constraints and then add them back again. To summarize that procedure, I have here illustrated the commands that you would need to alter your table. To remove the constraints, you need to know the constraint's name. If it's any constraint except a primary key constraint, since there's only one, you don't need to know the name there. And to add them back, you use this construct that I just showed you for foreign keys or this construct for primary keys. Now, maybe you want to drop the constraints, but you don't know what they are called. If we go back again to MySQL Workbench, remember that I said, here's a table that has some constraints, that what you can do is you can right-click on the table, copy to the clipboard the create statement for the table, and then paste it here. And what you'll see right here in the whole create table statement that I just pasted, you'll see all the constraints. These are all the foreign key constraints. Up here is the primary key constraint. And you don't have to worry about all these things that are specified as keys. These are the keys that are automatically generated whenever you add a foreign key constraint. So that will happen automatically for you. Next, you might be here because you're having query timeouts. The first thing to know in the area of query timeouts is that there are certain indices or indexes on your table that are created automatically. You automatically get an index if you declare a primary key. You automatically get an index if you declare a foreign key. So it's never necessary to add an index for your primary key or your foreign keys. But you may have a scenario where you're doing a select, perhaps without any joins or subqueries, but with a where clause, and it times out. In that case, you should consider adding an index on each attribute being tested in the where clause, if there's not one for that attribute already. Also, you might experience a timeout when you're doing one or more joins. In that case, you could consider adding an index on each attribute used in the on clause for the join. Those attributes are called join attributes. Let's look at an example using the same table that we've used previously. If I do a select without joins or subqueries with a where clause that tests one attribute, it takes about 3.5 seconds if that attribute is not indexed, but it takes about 0.4 seconds if the attribute is indexed. If I do a select query with 2 joins and a where clause testing one attribute and nothing is indexed, it takes about 4 seconds for that query to run. If I add an index for each join attribute, then it takes about half a second. Okay, so let's take a look at that. So here's the command with the select that is looking up values in the table that have a domestic origin state of 34, which happens to be New Jersey. Okay, the first query is the one that takes a long time because there are no indexes on freight source, and the second query is the one that goes much faster. So one way to find out if indexes exist is to do that copy command of the create statement and look at it and interpret it. A more straightforward way, perhaps, is to execute here, as I'm showing, the show indexes from table name command. This shows us all the indexes that are on the freight table. In the first case, we get a sequence number here. This is the primary key, which has many attributes in it. Once we get past the primary key, we get a bunch of indexes that are named for foreign keys, and we get the column that's indexed. And so if you see here, we're using domestic origin state, and we can see that there's an index on domestic origin state. That's what makes this query go faster. If we look at the joins now, here in this query, I have 2 joins. And the 2 joins I have are to join the origin state with the state table, so I can use the actual descriptive name of the state rather than a number. And I join the destination state with the destination state description. And this description is not indexed, so the performance of this query is and the next query differ only on whether there are indices on the join attributes. And the join attributes, again, are origin state and destination state and freight source, and then the state field in the state unindexed table. This query takes roughly 4 seconds. Right? If, on the other hand, I actually use the original freight table, which has foreign keys on domestic origin state and domestic destination state, as well as on the state field in the referenced state table here, then the query takes half a second. Now, let's take a closer look at what this query does for a moment. What this query does is it lists each distinct pair of origin state and destination state. That happens because we have a group by, so we're forming groups for each distinct pair. And then within each distinct pair, it calculates the sum of tons shipped between origin state and destination state in the year 2018. And it does this specifically for only the cases where the origin state is New Jersey. And then it lists them out in destination state order. We'll come back to this query in a moment, which is why I explained it to you. Okay, so if you need to create an index, rather than just add a primary or foreign key, the command to create an index is create index name. So maybe you call it name dot underscore IDX on the table, and the attribute in parentheses that you want to index, or a list of them if there's more than one. Okay. If you want to drop an index, you can just drop the index on the table name. You can also show all the indices from the table using this command. Use caution in adding indexes to production tables that are frequently written, because indices will slow down the addition or updating of tuples and tables, but they do speed up queries. Okay, so that's adding an index. Next, we want to talk about situations where you might rewrite the query, and the predominant situation for that is a correlated subquery that is painfully slow. Okay, so if you have a correlated subquery in a query and the query's timing out, you should consider converting that query to a join. Typically, most correlated subqueries can also be expressed as joins. If you don't see how to do that, then you might consider instead converting that subquery to 2 steps. One that creates the table generated by the subquery, and the second one that joins that table in to produce the result. So let's take a quick look at that. In my example, using the same table, I have a correlated subquery, and that correlated subquery times out. It timed out at 60 seconds, so I went and lowered the keep alive connection timer to 60, and then it ran forever. I lost patience and I stopped it. So that's one of the things I'll show you, is how to stop a query that you just can't wait for any longer. Then I took the same query and I rewrote it using an intermediate temporary table, as I explained earlier, and it took about 0.6 seconds. Then I used a different construct, which allows you to specify an intermediate table to be used once, and that's called a common table expression, or CTE, and the query ran even faster. So we're going to look at these 2 cases, and I'll explain to you why they're faster and why this one is slower. And then if we take the same query that used a join, which is the query I just explained to you, it took about half a second. So let's take a look at that. So here we are with our subquery, our query with a subquery. And so I'm going to start it running. While it's running, I'll explain to you what it's doing. This is not an excellent example of a query with a subquery because most folks would automatically do this with a join. But sometimes if you're thinking in the mode of a procedural or object-oriented programming language, you would actually come up with this. However, the database will not optimize this very well, and so it will be very slow. So I'm thinking procedurally that what I'd like to find are all the unique combinations of an origin state and a destination state, where the origin state is New Jersey. And then for each such combination, I would like to calculate the total tons that were shipped between those states in 2018. So here I have my unique combination, and here I have a subquery that is going to calculate the total tons for that. What makes this subquery correlated is this line here, which says for the destination state, in the subquery, dstate.description, I want it to match the destination state up here in the outer query. Okay, and so the outer query is just basically doing a big join to get the origin state and the destination state names on the line together. Okay, and restricting the list of interesting rows to those with an origin state of New Jersey. What makes this query so slow is that the database system will do this join, find all the rows for New Jersey, and then for each of those rows, it will actually call the subquery or execute this subquery. And it turns out there are a lot of duplicate pairs, right? Because some things might be shipped from New Jersey to another state by ship or by rail or by air. And all of these cases need to be our separate lines that have the same pair of origin state and destination state. So we're doing much more work than we need to. And that's also because distinct here doesn't mean just distinct origin state and destination state. It means distinct result row. And so the database system can't do anything but what I said because it has to wait till it calculates each value of total tons 2018 to see if the row is distinct or not. Okay, so at this point, I'm running this query. I'm probably pretty bored. And so here, you can always stop a query that's taking too long, so we'll stop it. So next, what I could do is just go back to the previous slide, right, and use this join here, because this join accomplishes what I want quite directly, and it did it in half a second. But if I'm not completely clear on how this is an equivalent query, another thing I could think through that would certainly help is I could take the subquery, okay, and for the subquery, I could create a table. So if we go down here, I'm going to create a table tonnage, which is basically the text of the subquery with the following revisions. I'm no longer going to refer to the outer query. I'm simply going to calculate these sums for every destination of a destination state with an origin of New Jersey. So I do that. It takes roughly 0.6 seconds. And then I write the final query that I was hoping to see a result for. I say, well, I know that the origin state is New Jersey because I just put it in this table. And I'm going to take each destination state from that table and the total tons, right? And all that I need to do in this case is to join with state in order to get the description of the destination state. And that takes 0.016 seconds. So if I run all of this, I get 51 rows returned. And if we look over here, it's basically the create table takes about 0.469 seconds, and displaying the final result takes practically no time. Another way to do this is you could use what's called a common table expression. And so I can take this tonnage table I created here, and with tonnage, so that's the name of the table I want to create, as I put the creation command for the table into a subquery, and then I run the final query. This takes less time. The reason it takes less time is that this with command here in front of the query tells the database that I want to create the table tonnage to use it once in the query that follows. So the database doesn't need to worry about writing this table to disk at all. It can keep it in memory if it's small enough, and then use it to execute the following query. And this makes it faster. This is, however, all one query. And so this one might time out when the two-step process does not time out, right? Because the two-step process is comprised of two separate SQL commands, and they are likely to both succeed, taking some portion of the time, when this one might be a little too long. So that's our solution for correlated subqueries. And it's in fact the case that if you have any kind of complicated query and it's taking too long, a good idea is to think about breaking it into steps with intermediate table results. This will often break it up enough that each intermediate step and the final step succeed, while the enormous query that you're thinking about overall fails. Hopefully, this has helped you to get around your timeout. When you're facing a MySQL timeout, don't despair. Do the following: adjust the timeout parameters in MySQL Workbench, choose the right tool for loading data, add constraints and indexes after inserting or updating large numbers of rows in tables, add indexes through primary or foreign keys or by using the add index command for attributes in the where clause or in the on clause of a join, and use intermediate tables so each step to the final result is quicker. If this video has helped you, please click like and consider subscribing. There'll be more videos coming in the future, and I'm always open to suggestions for things that would help you to use MySQL or other tech tools in business successfully. Thanks for joining me, and see you next time.